Hello world, it's Siraj. Welcome to my live stream. We are going to, in this video, be talking about building a social media Dapp with Polygon and Ethereum. So thank you everybody for being here today. I'm going to talk about several of the different aspects involving social media Dapps. We're going to be talking about all of the dependencies necessary to build a Dapp like this. Those include the Interplanetary file system, Ethereum, Polygon. There's a lot of different things that I want to talk about in this video. So thanks everybody for being here. I hope that this stream is working well. We're going to get started immediately. All right. So first things first, let me make sure this works. All right, great. This is working. All right. So, all right, first things first, here's a demo of the Dapp. It is a decentralized version of YouTube. And everybody knows how YouTube works. In fact, we're on YouTube right now. It is a video hosting platform. We take a video, we upload it to a set of servers that YouTube, the corporation, owns, and then they stream it to us, or they let it play for us via a central server. So this is all using the HTTP web. And what we want to do is we want to build the Web3 version of this using the stack of blockchains and distributed hash tables. All right, so the first step I want to show you here is how this works. So let me just play one of these videos. This is an example of a video that I've uploaded to the Interplanetary file system.
Reuse my weights.
So you can see that this is a video I've uploaded. It's hosted on the distributed hash table that is IPFS. You see a few other videos here that I've hosted. And if I want to, I can just choose another file and I can host it right there. You know, I can pick a video, you know, what's a good video for me to host, demo. I can find some random video here, and then I can just go ahead and upload it as an MP4 file. You know, it's looking for MP4 files. So here is an MP4 file, 20 megabyte file. I can choose it. I can give it a title like yo, click upload, and using my hash, it's going to open up Metamask, which is a web wallet for Chrome. It's going to ask for a transaction amount, a gas fee. I will then confirm that gas fee, and then it's going to upload it to the network, just like that, okay? So how do we build this? So first, I want you to go to this website right here. I'm gonna post it in the chat. It's github.com/AchillesTeeth/DTube. Now, this is the repository that we're gonna be working with. DTube is a decentralized video sharing and social media platform on the Ethereum blockchain. So let me post this in the chat right now as the starting repository. And what we're going to do is we're going to be building a smart contract in Solidity, which is the programming language of Ethereum, to be able to host our video content on the Ethereum blockchain and the Interplanetary file system. All right, so first things first, let me pull up the dependencies that we're going to use. The first dependency we're going to use is Ethereum. Now, Ethereum is the #2 cryptocurrency by market capitalization. It is a Swiss Army knife of sorts because it is, unlike Bitcoin, a blockchain that allows developers to build decentralized applications on top of it. What that means is not only does the blockchain store transaction history and data, it also stores programming languages, namely Solidity, and the ability to compile these languages and run them just like a computer. So just like any other centralized hosting service like Heroku, Ethereum does the same exact thing, except it's not owned by any single entity. So Heroku doesn't own it. Nobody owns it. It is hosted by a network of nodes, and everybody individually owns it. All right, so that's Ethereum. We're going to be talking about how to upload it to Ethereum. And the problem with Ethereum is that Ethereum, as great as it is, as many decentralized apps that have been built with Ethereum, there are still two main issues with Ethereum. The first is that gas fees are so high. And hold on, there's some noise coming in from my place. Let me just move some things around and make sure that there's no noise. Okay, there we go. Okay, so the first thing with, first problem with Ethereum is that there are so many high gas fees. It's really expensive to build anything on Ethereum. And the second problem is that transaction times are really slow because the network is so congested with the amount of data on the network. We want to make sure that transactions are fast, they don't cost a lot of money, and the way to do that is by using what's called Polygon. Now, Polygon is a separate blockchain from Ethereum. It's not Ethereum, it's a separate blockchain. And it is right now it's operated via the proof of stake consensus mechanism. And there are a set of what are called validators on the network. You can sign up to be a validator that are validating transactions on the network. And because the network is smaller than Ethereum, all the transactions that are happening on the network are much cheaper and they're much faster. And what happens is that every set interval, there's a checkpoint where the validators will send all of the transactions to the Ethereum blockchain. Ethereum will then validate that all of the transactions that happen on Polygon are indeed valid, and it's going to post an immutable hash on the Ethereum blockchain that represents all of the activity that's happening on Polygon. So what this allows us to do is build decentralized applications that solve the blockchain trilemma, which means that not only can they be scalable, they can be decentralized and secure, right? So we get scalability, we get decentralization, and we get security, all three, by using this layer 2 solution. And Uniswap, one of the most popular DeFi platforms, just used Polygon for all of its transactions. So they converted to Polygon, and you can see with the price of Polygon, things are absolutely skyrocketing right now in value because it is the way that Ethereum developers can build scalable applications without high gas fees and without slow transactions. So we're going to be using Ethereum, we're going to be using Polygon, and in order to build our web app, our Dapp, I should say, we're going to be using two libraries. The first one is called Truffle, and Truffle lets us build smart contracts for Ethereum easily. The second one is called Ganache, and Ganache is a test blockchain that we can use to test out all of our functionality before we deploy it to the main net. So we don't actually have to use any real money. Now, remember in the demo Dapp that I just showed, whenever I clicked on upload, this little pop-up showed up. And this pop-up is called Metamask. And what Metamask is it is a browser extension for Chrome that allows us to have a wallet in the browser and interact with any Dapps in the browser. And we're going to be using Metamask to make transactions. The last thing I want to talk about here in terms of dependencies is called the Interplanetary file system. So whenever we post programming languages compute to Ethereum, that's all great, but we're still limited by the storage space. We want to be able to have storage space that is not limited by the Ethereum blockchain. We want to have enough storage space to store, say, a decentralized YouTube. And that's where IPFS comes in. It's called the Interplanetary file system. And I want to be very clear, IPFS is not a blockchain. It is a distributed hash table. That means that just like any hash table, like a database, all of the files that we upload to this system are, instead of being stored on a central server, they are sharded, they are split into many multiple files, and they are spread out across the network. So anybody can be a host, a node in the IPFS network. And every file that we upload is given a single 25-character hash that represents that file. And the way that these nodes are incentivized to store our data is with a different blockchain called Filecoin. Now, we don't have to worry about Filecoin when we upload our data to IPFS. So one way to think about it is that Ethereum is the immutability layer. It's a pointer to where the data is stored. It's also where the programming languages are being compiled. And IPFS is where the actual storage is happening. And the way we're going to interact with IPFS is using this website called Fleek. Fleek.co. Fleek is essentially a hosting platform that uses IPFS on the back end, and it's got several IPFS nodes, so we can just simply upload via a web interface, and it's going to be stored on the IPFS network. And of course, we're going to be using node.js to build this JavaScript library, and npm, which is the node package manager, to install any dependencies. So first things first, let's get to this application here. You can see that this developer, Akhilash, already has a demo of it on the web right here. We're not deployed to the right network. We need to be deployed to the main Ethereum network, so we're not going to do that. But we're going to build our own version of this Solidity smart contract, and we're going to follow the steps here. I'm going to go through every step here so you can see how it works, how it's not that difficult. You just have to download this starting repository, and then you can be able to run this initial demo application, and then we're going to run this code, okay? So let me make this a lot bigger here so we can see what's going on here. And we will cd into the directory D2 main. Okay, so let's go through the steps here. What's the first step? So the first step is we need to open up the Ganache blockchain. So what is Ganache? I had already talked about what Ganache is. We want to be able to, let me remove all of this. You can see I already have Ganache running here. So I'm going to close Ganache and I'm going to reopen it. So I'm going to open up a fresh terminal window. Okay, and I'm going to run Ganache. So if we go to Truffle, we go to the GitHub repository for Ganache, we can then do an npm install of Ganache to install it directly. I'm going to npm install it, see if there are any questions here. Okay, thanks guys. Let me sudo into this. Okay, I'm going to sudo into this, and we're going to install Ganache. This is a one-click blockchain, okay? So this is going to install Ganache, and then we're going to run it. Okay, so it's installed, and now we're going to do exactly what it says. We're going to run Ganache command line interface. CLI stands for command line interface. So let's do that. Invalid or unexpected token. Oh, here we go. What is going on here? Invalid or unexpected token. So let me open up another window here. What is this error? I have not seen this error. You guys know the rule that whenever it's demo time, things just stop working. Just gonna quickly see what the problem is here. Okay, so I'm gonna run sudo. That might do it. Sudo sudo Ganache CLI. How about sudo Ganache CLI port 8700? Interesting. There's a syntax error here. This is in Truffle console. So this should be a Ganache CLI error. Unexpected token. Okay, so this guy's got an issue here. And we're going to see, you guys have any suggestions here? It is the Wild West. It is the Wild West. Okay. What's the issue here? Let me go back to where this is. Let's see, Ganache. It's like Truffle tutorial, and then we're going to go to the suite, Ganache beta. So we're just going to launch the command line version of Ganache. How about that? So that'll solve our problems. So we have our command line version, or not the command line version, the GUI, the graphical user interface. We're going to do a quick start on Ethereum. So this is going to quickly launch our test blockchain on Ethereum. And now it is running on this address right here. We have all of these account addresses, each have 100,000 ETH or 1,000,000 ETH, whatever that amount is. If we want the private key, we click on private key, and then we get it right here. We can insert that into our Metamask account. So we're going to do that in a second. But here is our test blockchain. It's running locally, and we can keep going here. All right, so that's the first step. We did that. Now we want to install our dependencies. So sudo npm install. It's going to install all of our dependencies using npm. And once we've done that, we're going to run Truffle Migrate. And what Truffle Migrate will do is it will take all of our smart contracts in this repository, and it will deploy them to our test blockchain. And we need to write these smart contracts. And once we write them, then we can deploy them, and then we can start the app with npm start. And if you guys have any questions, just post them in the chat. I'm going to be periodically looking in the chat to make sure that I've answered all of the relevant questions. While this is running, we got a bunch of interesting comments here. All right, cool. So this is going to take a while. So in the meantime, let's open up this repository that we've just downloaded. So it's going to be D2 main 4. I'll click on Sublime, open, and we'll see what we got here. So let's go through each of these class files one by one. So the first one are these two JavaScript files under migrations. So even before we talk about that, let's talk about what these folders mean. So Truffle is a framework for building decentralized applications, and it's always going to have these 5 folders. The first folder is the migrations folder, and what the migrations folder does is it's a set of JavaScript files that tells the EVM, the Ethereum virtual machine, how to deploy our Solidity contracts. And these contracts are written in Solidity instead of JavaScript because the EVM cannot read JavaScript, right? It's looking at bytecode. It's a very basic assembly-based computer. And Solidity is the closest to that assembly. It's the closest to the bytecode that we can get. Unfortunately, they're not higher level languages yet, so we have to write it in Solidity. It's also a very, very dense, compact language, so it's not very storage heavy. So that's a great thing because we want to keep things very small on the Ethereum blockchain. So right now it's got 2 default JavaScript files. Initial migrations is going to deploy whatever is in our migrations folder, and then deploy contracts is what's going to deploy whatever is in our contracts folder. Node modules is all of the node dependencies that we have installed. Public is where we're going to have our index.html file. What does our front end look like? What does that index look like? And as you can see here, it's pointing to a lot of different files we have. Like we have a PNG image, we have an ICO for the browser, we have a manifest file that shows where different things are. And then we get to this really interesting and probably the most important folder, which is source. And source is where we store our contracts. It's where we store our ABIs, which I'm going to talk about. And it's where we store our components. Now, this is not a normal HTML, CSS, JavaScript app. This is called a React web app. And React is a basic structure. React basically came out of Facebook as a library for building Web 2 apps, not Dapps. And it's a way of structuring our web apps so that our CSS, HTML, and JavaScript are very reusable. We don't have to keep rewriting code. What it does is it creates components that are reusable that we can just use over and over again, like a nav bar, for example. It's got this nav bar concept embedded in it, so we don't have to make a nav bar from scratch. We can just fill in what the nav bar looks like. We have a main.js file. We have an app.js file, which is the main JavaScript file, which we're going to put our web3.js code in. Web3.js is the only other JavaScript library we're using here besides React. React is to build the app. Web3.js is to let our smart contract backend functionality speak with our front end. And it displays on the front end as well. And when we upload a video via Solidity to the Ethereum and IPFS networks, Web3.js will pull that data from these networks and show it to the user on the front end. And that's what we're going to put in here. As you can see, we're initializing Web3, et cetera, and then we're displaying the videos that we have with each of them. Then, of course, there's the contracts folder where we'll have the Solidity files. And then we're going to have one more folder, which is test. Now, test, we don't actually have to think about too much. Test is this test suite like any great software application. We want to have a suite of tests that we can test in the browser, and it'll show us what we need to do so that there are no bugs in the code later on. And last but not least is the config file. Now, the Truffle config file is very important because it does 2 things. The first thing is it tells our Dapp what network to deploy our Dapp to. It could be the Matic or Polygon network. It could be the Ethereum test network. And each of these has its own name. And each name has its own network ID. It has its own minimum gas price. And then it has a URL to access that blockchain, a Web 2 URL that acts as a gateway to the blockchain itself. So you can see for Polygon, there's an RPC link called rpcmumbai.maticvisual.com and then the hash for that. So that's the one we're going to be deploying to. So when we're building apps that are scalable for Ethereum, we can actually point them to Polygon. We don't actually have to point them to Ethereum because what the Polygon network does for us is it will deploy our app to Ethereum, but we don't have to deal with high gas fees and slow transaction times. It takes care of that for us. Okay, so if you're an Ethereum developer, you are also automatically a Polygon developer. Okay, so those are the components. One more folder I want to talk about are ABIs. So these are application binary interfaces. Basically, when we have a smart contract, it's compiled into what's called an ABI. This is a JSON file that is readable by the blockchain. And there are ways of creating ABIs automatically. We don't actually have to do all that. It will do it for us, and I'll talk about that in a second. Okay, so we did an npm install. This should be done now. Okay, it's done. And now we're going to, I should have done sudo here, that's fine. Now we're going to do Truffle Migrate. And what Migrate will do is it's going to take all of our, okay, so before we do Truffle Migrate, let's write one of our smart contracts here. So I'm going to create a new file. I'm going to call it test. I'm going to save it as dtube.sol. Now this file has already been written. By the way, I just want to say it's already been written. But the reason that I'm showing it here is because I want to go through the process of writing it with you guys so you can see what it takes to write a Solidity smart contract. And we can talk about what each of these features mean. Let me see if there's any questions here. Webcam screen is too big. Good point, good point. Thank you for that. Let me make it a little bit smaller here. Okay, so yeah, I'll avoid the bottom right. Let me see, there's one question here. All right, so just wondering, why did you choose this Framework SDK specifically? Rebel Science asks. Let me answer that question. Have you seen Morales SDK? It literally has anything you want to build at Dapp and has the best docs I've ever seen. The reason I chose this is not because I'm a Polygon fanboy, it's because I'm an Ethereum fanboy. And I have been trying to build Ethereum dApps for literally 7 years now. Look at my book, Decentralized Applications, Harnessing Bitcoin's Blockchain Technology. A lot of it was having to do with Ethereum and IPFS. In fact, I had a course called Decentralized Applications. And so many students had so many great applications that they posted. But the problem was that they were not scalable. That was the issue. These things were not scalable. And now, finally, in 2021 and now 2022, we have the technology to scale our decentralized applications. And Polygon is the best solution to do that because it is the largest network, it is by market cap. It has the most user growth, the most daily active users, DAU, that's the metric, and it's the most reputable. It's been around for a while. Look at the founders, Sandeep Narwal. We've got Mihailo Belek, Estonian dude. We have some people who've really worked hard in the blockchain community for many years, and they're very dependable, and I trust them. So one thing about trust before we start building the Solidity code, we have this idea of trustless systems that we're building with these dApps. We need to stop thinking about it this way. The need to trust will never go away. What we're trying to build are trustful systems, more trustful. As humans, we will always have to trust other humans. There's no getting around that, no matter how much we automate things. And so, even if we're trusting Ethereum, we're still trusting the miners to mine the coin, or the stakers to stake, the validators. Trust will always be there. So this is the most trustful system I can think of. All right, so as with any smart contract, this is going to be the main smart contract that we're building right now, okay? As with any smart contract, we want to start off by representing what version of Solidity we're going to be using. And in this case, the latest version is 0.50. Now this contract is going to be called D2 for Decentralized YouTube. And when we start this contract, we're going to specify a few different public variables. The first one is going to be called video count. And I'm calling it video count because this variable is going to start off with as 0 because there are no videos yet, but it's going to be a counter variable. It's going to increment by 1 every time someone adds a video to this decentralized network. It's called uint because it's an unsigned integer, which means any integer that is non-negative. So 0 or greater, you must specify as a uint in Solidity programming. The next public variable we're going to be using is called the string, which is D2, the name of this dApp. And we're going to create one more public variable, and this public variable is called a mapping. And what this mapping does is it's going to tell us, it's going to show the smart contract what to assign, what number video to assign to each video that we use. So say video 5, it's going to have its own unique hash with IPFS. And 5 and that unique hash are going to be connected to each other via this mapping right here. Okay, so but let's create, you can notice this uppercase video. What is this? Is it a class? Is it a variable? Well, let's define that data type. And in Solidity, we define data types as structs, structures. Okay, this is the closest thing to a class object that we have in Solidity programming. Now, every video is going to have its own unique ID, right? So what's the count of that video? Is it video 5? Is it video 1? Is it video 15? 5 million? What's that ID? The next thing each of these videos needs to have is a hash. And this is the IPFS unique hash for that content address. In the current web, we have no content address. It is an IP addressed web. But in a Web 3 version of the web, data is not IP addressed. It is content addressed. That means that rather than going across the universe, across the world to get some piece of data, be it an image or a video, we're just going to look for the nearest content address to you, and then we're going to serve that to you. And that's going to be infinitely replicable for as many hashes as we have. Okay, so that's that. We have a title. What is the title for the video? And then the last parameter that we have is the author. What is the wallet address of whoever uploaded this video? Those are the 4 parameters we want to have for this struct. Now the next thing we're going to create here is an event. And an event in this case is if a video has been uploaded, we need a set of parameters to display in the user interface. So again, it's going to be the same thing. In fact, we can just copy this right here and we can paste it right here because this is going to show what the event is. And let me put commas instead of semicolons for each of these because we don't need semicolons, we need commas. All right, so and well, actually, we do need semicolons, never mind. For events, we need commas, but for the rest, we don't. So so we have that down, and let me just keep going here. So we have one more, we need to make a constructor, by the way. So the constructor is going to be public, and in the constructor, we want to have a single function. Now, this is the last function that I'm going to be writing here. The function is called upload video. Now, this is our main function, okay? Function upload video is going to take several parameters. The first parameter it's going to take is the memory. So the memory of the video hash, that's what video are we uploading, it needs to know. And it also needs a title. What's the title? Using those 2 things, and it's a public function, it's going to upload a video. And before we actually upload the video, we need to make several requirements. The first requirement is that we need to make sure that the video hash exists. So we're going to say, does this video hash exist? And how do we say exists in Solidity? We say, is it a non-zero integer? So that is it more than 0? So if it is more than 0, that's the first check that it's passed. The next requirement is that the video title has a length that's greater than 0. So we also have to make sure that the title exists. And the last thing we want to require is that the uploader address exists. So those are the 3 things we want to make sure exist. So whoever is trying to upload a video, the message.sender, whoever is sending a transaction to this smart contract, there are 2 types of contract addresses in Ethereum. There is a user contract, and then there's a payable machine contract. So smart contracts have their own address, and then users have their own address. And we want to make sure that the message sender, their address is 0. Okay, so that they exist. That's essentially what we're saying. Do they exist? And if they exist, great. We'll go ahead and increment the video ID by 1. So video count plus plus. And we've done that. We've made our requirements. We've incremented the video. And now comes the actual video upload part. We have an array of these video structs that we are going to look at the count of. So whatever the video count is of this video, we're going to say take that video and give it the video count, give it the video hash, and give it the title. What else? We need the title, we need the address of the sender, so whoever is uploading this video, and that's all we need for that. And the last part is we need to trigger this event. So remember that event we had up here, a video uploaded, let's trigger it, and the emit keyword is what triggers an event. So say emit video uploaded, and then video count, and again, same stuff, video hash, the title, and the message dot sender address. That's the address. That's it. That's it. And most of this functionality is going to come in the form of IPFS. Okay, so that's where we're actually uploading the videos. And that is, let me just see if there's any questions here. Will a recording be available? Yes, this will all be recording. The struct should be written inside the contract block. You might be right about that. Struct, I think you're right. Yep, you're right. Contract, yeah, it needs to be written inside of the contract block. Correct. So let me remove that. Put the struct in there. And in fact, the whole thing is a contract. So I'll just put that there. Is IPFS using Filecoin under the hood? No, it is not using Filecoin under the hood. Filecoin is a separate blockchain entirely. Okay, so that's it for the questions. Let's just go back here. Now let's compile this thing, okay? But before we compile this, let me look at anything else I haven't explained. So we have an index file, and that's what's just displaying things to the front end. We have some ABIs. These are already pre-compiled. We don't even have to worry about these. And then we have some CSS. We have the main app.js file, the footer, which is the footer. We have a main.js. All this is just HTML, nothing too important. Navbar. But this app.js file is pretty important. So let's go through this really briefly. This app.js file right here. So the app.js file contains the front-end logic for our Dapp. Okay, so what does our Dapp's front-end look like? So we're going to use web3.js and the IPFS client to initialize our Dapp as a client to the IPFS network. And when we create our app, we're going to say load web3, load the blockchain data, and what else? We're going to say load web3, load blockchain data, and then we're going to display it for the user. It looks like this is freezing right here. Okay, great, it stopped freezing. We're going to load all of the web3 accounts. So we're going to initialize web3, load all of the Ethereum accounts. So this is going to be on Ganache. So it's going to be a bunch of test accounts. We're going to get the ID, whatever data is there in the network. We're going to connect to that DTube smart contract that we just coded. We're going to retrieve that. And then we're going to retrieve all those parameters that we just initialized inside of that contract. We're going to display them for the user in the front end. So from that contract that we just pulled right here in JavaScript, pure JavaScript, we're going to pull the video count. Okay, we're going to pull the hash. We're going to pull the title. All of those parameters are now accessible in the front end of our application using web3.js. Okay, and when we upload a video, it's going to, in the console, say, we're submitting it to IPFS. And this is where the actual video upload happens. The smart contract just creates pointers for all of this. Remember, just like any sort of C++ pointer, it's the pointer itself doesn't store the data. The pointer just points to where the data is stored. And the data is stored on IPFS, okay? So once that hash has been created with Ethereum, it's going to be uploaded to IPFS via this JavaScript snippet. And then we're going to set the state of the network to that new state. And then we're going to upload the video, capture the file, and these are just helper files right here for rendering. But that's it. I mean, if you think about it, it's not that big a Dapp. It's actually pretty small for something as powerful as a fully scalable, decentralized YouTube competitor. Like, that is very ambitious, wouldn't you say? And I didn't talk about this migrations .solidity file. This migrations file simply migrates all of our contracts to the Ethereum blockchain. Okay, so let's deploy this together. And then let's see if there's anything else I need to talk about here. So in D2, you can see in Metamask that I have it connected to the test Ganache blockchain. You can see all of these addresses. They're all showing up here. It says localhost 8545. You can see all of my test accounts here with 99 ETH and all of these contract interactions that I'm doing. So it's connected here. You can see the file. I'm uploading videos left and right here, and it's running locally. Now, here's the next part. This is great. This is decentralized, but I don't want to host this on my local computer. I want to host it on the web so anybody can interact with it. So what I could do is I could upload this to AWS. I could upload this to Google Cloud. I could upload this to, Azure, but then that defeats the whole purpose because Azure is stoppable. Some government could stop access to that URL. We want it to be truly decentralized. So what is a developer to do? What we are to do is we are to use this service called Fleek. And Fleek is super easy. We're going to sign in right now. It is an interplanetary file system storage hosting service. And we're going to sign in with my GitHub. So once I'm signed in with GitHub, it's really easy. All I need to do is connect a GitHub repository to Fleek, and it will completely deploy a site for me. So I'll connect with GitHub. It's going to list all of the repositories that I have here. I'm going to say this is a DTube, I think. So I already have it uploaded to my GitHub. I'm going to select DTube. I'm going to select, I want it to be hosted on IPFS, continue, and what is the framework here? I think it's, we have React, so I'll select React. It's going to run the build commands, and I'll click deploy. One-click deploy to the decentralized web in progress. We can see it here in the log. What's happening? It's going to run npm install, npm run build, everything we need, and then it's going to give us an address that we can view on the web to view this decentralized app. All right, let me see if there are any questions so far, and then we'll keep going here. Okay, thank you for the spelling. Interesting questions. How do you avoid disinformation and information bubble crises in the social media Dapp? That is a really great question. So disinformation, and so first of all, anybody can upload anything to this Dapp, whatever, there is no restrictions whatsoever. So that means a bad actor could definitely deploy disinformation to the Dapp. But like I said, the need to trust will never go away. The difference between this Dapp and a different Dapp is that everything that's uploaded is on the blockchain. So we can see the address of whoever posted it. And reputation does not go away. We can see who the address owner is of any set of videos. And if somebody is consistently posting great videos from their address, if we see some disinformation, we can just look on the blockchain and see who is actually posting this. And if they're just posting only disinformation, then we'll just know that, hey, this is not that, this account is a disinformation account. We shouldn't be trusting it. But I do think that that's a really hard problem. We need to be very vigilant about this. The second question is, so it's hosted on GitHub. No, it's not hosted on GitHub. It's just uploaded. This repository is uploaded to GitHub, and then Fleek connects to GitHub. It's taken, the repository is taken from GitHub to Fleek, and then Fleek will upload it to a set of IPFS nodes that they control. And then it's hosted on those nodes. And then the more people that use the Dapp, it's going to use. I do think disinformation is a problem I thought about for quite a while. It's a really hard problem because, with deepfake technology getting better and better, how are we going to know if anything is real or if anything is fake? It's like a constant game of cat and mouse for security, right? Like the better we get at creating fakes, the better we're going to get at detecting fakes, right? The better we get at one, we're going to get better at the other. So it's a constant battle between good and, I guess you can say, evil. And there is no end solution to this. It's going to continually, every new problem that we solve is going to create a new set of problems. And that I quote from the book, The Beginning of Infinity by David Deutsch. Highly recommend this book. I love this book. More questions. So does the Fleek address come back as IPFS or HTTP? It comes back as HTTP. You can see it right here. Here is the HTTP address, and it's updated on the DNS, which is Web 2, except it's hosted on Web 3, which is awesome. This seems very complex and non-secure to move money. Why do we not create a new internet instead of trying to cheat the existing one? I guess you could say it's complex, but every new technology is very complex at first, and then it gets easier. Like, I promise you, this stuff was a lot more complex even 5 years ago. And I can also promise you 5 years from now, it's going to be a lot more easy to use. Like today, it's so easy to make a Web 2 app. You download a Node.js, you download NPM, and then all of a sudden, you have a Hello World app running locally on your browser. JavaScript does everything. You don't need to know any other programming languages. This was not the case 10 years ago, right? You had to use a bunch of different languages. Now it's just JavaScript all the way up and down the stack. You can use JavaScript for GPU programming. You can use JavaScript for machine learning and artificial intelligence, matrix operations. You can build a neural network in JavaScript. 10 years ago, no developer would have ever believed that, but here we are. And the same is going to be happening with these Web3 tools. One more question. Who owns the nodes? Where are the physical servers if not GitHub? Radeon asking the right questions. So in the case of Fleek, the nodes are hosted by an anonymous set of nodes that are a part of the IPFS network. What Fleek as a service does is it pays them in Filecoin for us, at least for free. Now notice there's a billing tab right here. So right now we're on the basic plan. It's running on the freemium model, which most internet services do, but as we scale our Dapp, we're going to have to pay them, and then in whatever currency, and then they will pay the nodes in Filecoin. So remember, there's no free lunch. We still have to pay some price for hosting some huge Dapp that scales. There's no free lunch. And Filecoin is amazing. It is a protocol built on top of IPFS. It has nothing to do with IPFS. It's just a blockchain that incentivizes IPFS nodes to store our data, because right now there is no incentive, right? We need there to be an incentive. Okay, so I want to say a few more things. First of all, if you're interested in learning about how to build these decentralized applications, definitely go to Figment. Figment has the best tutorials on Polygon and Ethereum out there. In fact, this is something that I learned from a Figment tutorial. Anything that you want. These are all application-ready dApps. Peer-to-peer payments, 3D art gallery, NFT sharing, lending, polymarket betting, social media, to-do apps. There's so much that you can build. You just go to learn.figment.io to build a Dapp using Ethereum and Polygon. And there's so many different things that you can build with this. If you go to awesomepolygon.com, you can see the thousands, there are literally thousands today of dApps that are built with this. These are in production dApps with sometimes billions of dollars of capital that are locked into these dApps. These are completely decentralized. Nobody is controlling them. A community owns them. Look at this, $27 billion is locked into this protocol that we're accessing via the HTTP web, even though it's not a company. AAVE is not a company. It is a community. And we can make proposals, we can vote on it, we can make changes to the network using Ethereum and Polygon. That's what this is built with. So I want you to definitely check out those links. And also I want you to check out this link right here, Preddy.finance. Here's a dApp that I've been looking at for a while. Basically, the network is not supported, but if I switch my Metamask to the official Ethereum mainnet, it's going to connect. So now it's connected. And this is a way for you to look at ETH calls and ETH puts. You can look at your account information, the price of Ether. You can make trades as well. Anything having to do with decentralized finance, you can use with Preddy right here. What's the price we want to look at? What do we want to do here? This one's really cool. Preddy.finance, they have a Twitter as well, Preddy.finance on Twitter. Really cool dApp that I've seen here. They've got a Discord, definitely look at that. Sustainable option trading for everybody. A lot of different financial operations that we can do now. Even if you don't have access to a bank, it's pretty incredible what we can do today. Let me answer 2 more questions and then we're going to end this live stream, okay? Yeah, I can test it out for us right here. Here's a question. Here's a question right here. If I'm learning to build Dapps by Eddie Trevino, how can I see the code of other running platforms to break things down and learn in that sense? That's a great question. So Eddie, check this out. Remember I just showed you this thing, AAV? This is, imagine if a bank had $27 billion locked in it. Do you think they would show you their source code? Absolutely not. But that's how Dapps are. Dapps are totally open source. So I bet you, if we go to GitHub, we type in AAVE, we can literally look at the source code. Boom. This is the most recent deployed protocol for AAVE, Aave. So here's one, Aave. And this applies to any platform that is built on the decentralized web. Everything is open source. Everything, SushiSwap, Uniswap, all the swaps, 0x. Just take a look, find one of these, and then go to GitHub, search the name. I'll say Augur, for example, decentralized prediction market. I wonder how that works. Let me go back to GitHub. Let me type in Augur. Let me see, how does Augur work? Boom. Prediction market protocol, right there, V2, updated 11 days ago. Here's Augur right here. Everything is here, right? So this is a great way to learn about how these apps work. And this is how we're gonna accelerate development for Web3 and eventually Web4, whatever that looks like. One more question and then we're good. Is a live video gonna be uploaded? Yes, it's gonna be recorded. Why are deploying Dapps so expensive? It's because the cost of mining right now. Right now, Ethereum uses proof of work mining, and to maintain all of these machines, it's very expensive. Miners have to be paid the right amount of money, and scalability is the issue of Ethereum. If you're interested in learning more about how that works, I would suggest Vitalik's latest blog post, Vitalik, I think it's like CA. This blog post right here, Endgame. Endgame is really good. He talks about zero knowledge rollups, which Ethereum just bought Polygon just bought all of these zero knowledge rollup startups, like billion-dollar acquisitions. Really cool stuff. You can see the technicalities behind how this is going to work, how scalability is going to work. And I do think that Web3 is now the most exciting space for a developer to be, because we're living in a world where AI has become entirely centralized. Unfortunately, like 100 trillion parameter models are being released by companies that require tens of millions and often hundreds of millions and even billions of dollars of capital, which an everyday developer doesn't have. And that's not very exciting, right? We want to build impactful applications that can provide real value to people today. And the way to do that, I believe, if I were a young developer getting started today, would be to build a Web3 application. What can Stripe not do? What can hospitals not do? What can Web2, Twitter, Facebook, Meta, Apple, NVIDIA, Google, what can they not do? What is possible today with fully unstoppable decentralized applications and with unstoppable infrastructure? That is a question that we should all be asking, because the future of the web and the future of the world depends on us building these applications today. Like, this is human evolution at play. We are watching it. It is such an exciting space to be in right now. And if you're interested in learning more about this as well, go to my Twitter page and just follow everybody that I'm following. So just go to Twitter, go to following, because I'm following some really cool people in Web3, and just follow them, because that's where I'm learning so much about Web3. Just every day I go on Twitter and I look at different things and different updates in the space. It's so exciting right now. So yeah, that's my suggestion for you guys. Thank you for being here today. Awesome to see Eddie. And one last question, I swear, and then I'm done. KG asks, outside of finance, what problems do Dapps solve at the moment? So outside of finance, there is healthcare, right? How do we, so much can be solved in healthcare if the data was just public. If people could have access to breast imaging data and neuroimaging data and heart rate data, all of this is private. But if it was public, then developers could access it, and we would accelerate development towards building things like health insurance, decentralized AI, all this stuff. So healthcare, supply chains, how do we take a set of parties that don't trust each other or know each other, and how do we create a connected network that involves all of them? Again, blockchains. What other industries? Health, finance, supply chain, marketing. Okay, so thank you everybody for being here today. I really appreciate it, and I will see you soon. I love you all. Mark, Lee, you, Simba. See you soon, all right? Bye.